Okay, now let's look at some transformations of the original data. And transformation of the original data is required, the purpose of that is when you look at very simple forecasting methodologies, those simple forecasting methodologies are appropriate only if the data is fluctuating around a constant mean. In other words, what is called stationary time series. It doesn't increase over time or decrease over time, but it just fluctuates. There is some randomness, but the randomness is around a constant value that doesn't move up or down. But oftentimes our sales data would be increasing or maybe changing by seasonality. Okay. Let's first take the trend case. Trend meaning there is a constant increase, and then your actual data fluctuates around a mean that is actually gradually increasing. So if that is the case, one of the easiest way to handle this kind of situation and still use the simple methods of averaging methods, we'll be looking at that in the next chapter, is to, instead of looking at the actual values, you look at the difference in the values. And if we assume that going from one period to the next, the amount of increase remains relatively stable, then we can use this first difference, which is a constant growth model, and try to predict the difference instead of predicting the actual value. So once you come up with a prediction for the difference in the future time period, then we can take the actual value of the current time period and add to that our estimated difference going from this period to the next period. So this difference being constant, so these difference would fluctuate around a constant value, so the simple methods will be accurate enough. It'll be useful. And another way of looking at the difference is, suppose if the difference is not constant, but if that difference itself is increasing over time, then we can use a growth rate transformation where you take the difference like before, but you express that as a percentage of the current value. So the percentage change remains the same over time. So the second transformation is useful if the difference going from one time period to another time period is not constant, but the rate at which it is increasing is constant. So let's look at these two transformations in Excel next. Now here is the Dallas airport data. We were talking about airline passengers. So let's first start with a time series plot, okay, over the year. So year being the x-axis and number of passengers being on the y-axis, and we can plot a scatter plot like this. Okay. So this is time series plot of passengers. Now we drew this graph earlier in that tab. Okay, so this is the original data, and let's add axis titles, and this is here. Okay, and as you can see, even though it starts off steady, there is a gradual increase in the average value over the years. So this is a good candidate for using one of the transformations. Suppose if we take transformation of difference. So a given value minus the previous value. So you can only start from the second year. So you go the current year value minus the previous year value. So that's the difference. And now use this difference. Okay. Now if you plot the first difference, Okay, now let's do insert a scatter plot. Okay, now we need to specify the x-axis value for that scatter plot, which starts from year 1964 all the way to the end. Okay, now this plot is the plot of the difference, time series plot of difference. And we'll often it is called first difference because it is the difference of the first time period, one time period in other words. And as you can see, at least during the early years, the difference is about constant, and there is a lot of variation here towards the end, but this difference has at least taken away the trend part. So now we can use this difference as a starting point for forecasting, and once you come up with a forecast for the difference, then you add that to y sub t minus 1, that is, you take the actual value of 16,964 and add to that the forecast of our difference, and that will be the forecast for year 2010. So this is the first difference approach. Okay, the next one is the growth rate transformation, where we take the difference, but you express that difference as a percentage of the actual value from the previous time period. Okay, so let's go to Excel. So we take this difference and you divide by the previous actual value. Okay, and we can express this as a percentage if you like, or you can just keep it like that. Okay, now we have the transformed values. Now let's plot this transformation and see how this one will look. Okay, we'll add the x-axis values. So it's the series x-axis values goes from 1964. Okay. Okay, let's put that in the third position. Okay. And this is a plot of growth rate. So this is the time series of growth rate. And the x-axis is the year. And this is the growth rate. Okay. Now you see that this transformation also removes the trend and makes it possible for simpler models to be applied. And also the variability towards the later part of the time series is dampened. So that makes it even better of a transformation than before. Now if you use this transformed data and come up with a forecast for the growth rate, then your forecast will be you take the actual value of 2009 and multiply by 1 plus the forecast for G expressed as a number and not as a percentage. Okay. There is one more transformation that we can do. Okay, that is a log transformation. We'll look at that next.